Hello everybody, this is Mr. Kusaj, and we are ready to start chapter 3. The title of the whole chapter is Exponential and Logarithmic Functions. So what are exponential and logarithmic functions? First we're going to look at exponential functions, right? What did we do so far? Well, we did rational functions, we did polynomial functions. Now exponential functions, what do they look like? Well, we did these power functions, but we didn't do these. What's the difference? Well, if you look, here we have x as the base, right? Here we have the other way around. X is the power or the exponent, right? So we're going to be looking at this. We haven't seen this type of function before. So what do they look like? What are the properties? What do the graphs look like? So let's start. First of all, if you want to graph really quick an exponential function, you should always start with -1, 0, 1, and you'll get the feel. You can kind of see which way the curve is going to go, the graph is going to go. So, for example, 3 to the x. What does the graph look like? Well, on the side, just do x equals -1, 0, 1. I did 0 first, so 3 to the 0, anything to the 0 is 1, right? And what about x equals -1, right? Well, 3 to the -1 is really 1 over 3, which is 0.3. So at -1, we don't go halfway up, we only go a third way up. What about x equals +1? Well, 3 to the 1 is 3. So for x1, 3. So we can see what the exponential functions look like. They're going to look like this, right? And there's some specific properties that we'll get into in a few minutes that always happens, right? You can kind of sense that, oh, it looks like it'll never go below 0. You're right. Okay, what if your x is negative? Well, won't you have the same answers but negative, right? It'll be like a reflection. You're right. So let's do one with 2 as a base. 2 to the -x, right? So 2 to the -0 is really 2 to the 0, which is 1. Oh, look, 1 again. It seems like for x equals 0, it's always going to come out to 1. Yes, think about it. Anything to the 0 power is 1. So it doesn't matter what this number is. If your x is going to be 0, you're going to be right here. What about -1 and 1? Well, -1 becomes +1, right? -1 becomes +1, so 2 to the 1 power is 2, right? And then the fraction part is for 1. 2 to the -1 is 1/2. So for 1, we go up half. So it looks very similar to this, except it's flipped over the y-axis. And it makes sense, right? All your x's are now, that were on this side, positive, now are on this side because it became negative. And all the x's that were negative on this side, and all the x's that were negative on this side become positive, right? Negative, and they flip over to this side. So all they did was like flip over. Okay? So let's talk a little more about the properties of this new function type that we're talking about. Exponential function. So what are the properties? What are some things that it always has? Well, first of all, let's deal with when the base is always bigger than 1. Okay? Like we had 2, 3, 4, 5, anything, right? Did you notice, well, let me bring back the other two. Did you notice the domain, left to right, is going to go through infinity, both directions, right? So it's going to go forever to the left and forever to the right. But the range doesn't go below 0. Right? From bottom up, it doesn't go below 0. So the range is going to be 0 all the way up to infinity. How about the intercepts? We always go through 1. Remember that? We always go through 1. When x is 0, we always go through 1. So our intercept of the y-axis is at 1. How about the x-intercept? None. We never go past this line, so we're never going to cross the x-axis. None. Asymptotes, we know what asymptotes are. Vertical asymptotes, there is no vertical asymptote, right? It's going to go all the way to the left, all the way to the right, and it's going to touch everything. But horizontal asymptote, yes. At 0, it's never going to touch this 0 line here, y equals 0. Right? What else? What happens in the ends? Well, as the x goes to the left, your graph comes lower and lower and lower and approaches 0. Right? As your x goes to the left. As your x goes to the right, your graph is just going to shoot up to infinity. Right? So these are the properties of this type of function. Get used to it. Get used to seeing them. Okay? Transformations, meaning what if you put numbers around here? What does it do? Well, let's compare it with 2x, for example. What if we put plus 1 here? What does it do? We know what 2 to the x looks like, but what does 2 to the x plus 1 looks like? Right, so here's 2 to the x. Here's 2 to the x, the dotted one. Goes through 1, just like we said. What about plus 1? Well, if you look, it goes the same direction but faster. So remember at the beginning I said always do -1, 0, 1, and you'll get the idea. So if you put 0 here, 0 plus 1 is 2. So at x equals 0, I'm here at 2. At x equals 1, I'm all the way up here. 1 plus 1 is 2. 2 squared is 4. Right? At -1, -1 plus 1 is 0. 2 to the 0 is 1. So at -1, I shoot up to 1. So now you see the curve. It's not parallel, by the way, but it is above 2 to the x. So it's shifted up a little bit. Okay, not parallel, because this is going to go way faster. Okay, what about 2 to the negative x? We've seen this, right? It's going to flip over, right? So here is 2 to the x. Negative x, just mirror image. This is on the right, so it goes to the left. This is on the right, so it goes to the left. This is on the line, so it stays on the line for both of them. Right? And lastly, what if we multiply a number in the front here? Well, we know what happens when you multiply a number. It'll stretch it. It'll make it go faster. But in this case, our number happens to be negative. So not only is it going to stretch it, it's going to flip it over. Right? It's going to flip it over. So not only is it going to go faster, but that faster is going to flip over. So it's going faster down because of the negative. Again, if you don't know how to get this, just plug in 0, -1, -1, and 1. Right? 0, -1, and 1. Right? 0, -1, and 1. So if I put 0 here, 2 to the 0 is 1. -3 times 1 is -3. If I put a -1 here, 2 to the -1 is half. 3 times a half is 1 1/2. -1 1/2. If I put a 1 here, 2 to the 1 is 2. -3 times 2 is -6. So way over here, when you put a 1, you get a -6. Okay? All right. I'm just about done. The only thing left to talk about is E, natural base E. So just like pi stands for 314, there's a letter that we reserve for this number that comes up very often in math and in nature. So E is reserved for 2.718. Okay, if you didn't know that, now you do, and your calculator knows it too. So look in the calculator, look for E, it'll do it for you. So just like before, At 0, right, e to the 0, e to is anything to 0 is 1. E to the 1, since e is 2.7, so 1 is going to be at 2.7. Right? So it's going to look like this, but if you want exactly the exact graph, you can do more points. I just want to make you aware that there is a graph e to the x. And of course we can put numbers around it like x plus 1 or 2 over here, etc., and we'd have to evaluate it. Right? So more transformation, except now we're doing e. So e to the negative x, remember what that means? That means it's going to go the other direction, and then we're going to add 3. So all the numbers are going to just shift up 3. Right? Isn't that what happened? It was supposed to go down here, then it flipped over, and it went up 3. The 1 became 1, 2, 3 up, right? The 2.718, which was over here, goes 3 up. 1, 2, 3. It was on the right side here, but it's on the left side here because of the negative x. Okay? What if you had half? Well, then it just shrinks down. Exactly as ex, but everything comes down by half. So instead of 1, it's half of 1. Instead of 2.718, it's half of 2.718. Right? Okay? So you should know that there is a natural base e function. So when you see the e, don't flip out. It has its own graph. Okay? That's it, believe it or not, for parts 1 and 2. That's all we need to know for 3-1. I'm going to leave you with these 3 try problems. All I want you to do is graph them, right? So they're all going to look similar, but depending on what's around them, it's going to be shifted a little bit or stretched. So negative x, you know what to do because that was in the example. Positive x, that was like the very first example, but it's with a 5 here. This is a quarter to the x and then add 1, which means it's going to, the whole thing is going to go shift up 1. Okay, do the best you can. Again, the way to sketch a graph is to replace x with -1, 0, 1 on all of them. Get those 3 dots, and you can see how the curve will go. Once you have 3 dots, you can see which way the curve is going to go. Okay, so I'll see you next time in class. Remember, this is parts 1 and 2, so don't go looking for part 2. You are done for section 3-1. All right, thank you. Bye.